essential question. How can you use the sine and cosine ratios in calculations involving right triangles? So we're still looking at right triangles. Learning goals. I can identify a sine, cosine, or tangent ratio for a given angle. So we already did the tangent ratio part. Today we're doing the sine and cosine part. And number 2, I can solve for a missing side length in a right triangle using a sine, cosine, or tangent ratio. We have already done the tangent ratio part of that learning goal, but now we're doing the sine and cosine part of it. And so these are the 3 different ways to look at ratios of the side lengths on a right triangle, the hypotenuse and the 2 legs, okay? And just a little bit of review to remind you, here's our right triangle. A right triangle has 2 legs and a hypotenuse. Okay, the 2 legs are the 2 sides that make up your 90-degree angle. The hypotenuse is the side opposite the 90-degree angle. And when we found the tangent of angle A, so here's angle A, we had to write a ratio of the 2 leg lengths, opposite over adjacent. So if we're looking at A, opposite was over here. It was this length over adjacent, which is this length. So adjacent means next to, opposite means away from. And so we saw tan of A already. These are the new ones though. So we have sine of an angle. The sine of an acute angle A is just written as S-I-N-A. The cosine of an angle for acute angle A is written as C-O-S-A. Trigonomic ratio. It's a ratio of 2 sides of a right triangle. And so we have 3 of those now. We have 3 trigonomic ratios where they are comparing 2 sides of a given right triangle. And so for the sine of angle A, so again, we have this right triangle here, and we look at where angle A is. It's defined like this. So the sine of A is the length of the opposite. Okay, so that's the same as tangent, right? We always start with the opposite up top, but the denominator is different. Now, instead of putting the length of the adjacent side, we're going to put the length of the hypotenuse. The hypotenuse is this side length opposite the 90-degree angle. All right, and if we look at cosine, then that ratio is the length of the adjacent. Okay, so we're looking at angle A. Depends on which angle you're looking at to figure this out. It's always one of the 2 acute ones. It won't be the right angle. It'll either be A or B. The cosine of A is the length of the leg adjacent to A. Okay, so that's this leg here, over the length of the hypotenuse. All right, so we're making ratios 3 different ways: tangent, sine, cosine. And to remember which way they go, this is the thing I was mentioning before this week, SOHCAHTOA. All right, it's fun to say SOHCAHTOA. It's easy to say, it's easy to remember, and it will let you memorize all the different ways of writing these ratios. Okay, so stands for sine, right? Because there's sine, cosine, and tangent. Only this one starts with S, only this one starts with C, only this one starts with T. Sine, so opposite over hypotenuse, opposite over hypotenuse. Cosine, cosine of A, adjacent over hypotenuse, A over H. And TOA, T-O-A. So if you can remember SOHCAHTOA, and you can remember all the different ratios, all the trigonomic ratios for a given right triangle. Okay, and so this example here is all for acute angle A, all right? So you have to look where A is, it's this one. And then in terms of A, B is always the adjacent side, okay? A is always the opposite side. And C is always the hypotenuse. Now, if I switch this around, I'm trying to find sine, cosine, and tangent of angle B, A and B get switched. Okay, so adjacent then becomes the side that's touching B, and then the opposite side becomes the one that's the furthest away from it. But the hypotenuse always stays the same. Okay, so C is always our hypotenuse. It's always the side across from the 90-degree angle. So we're going to do this slide together. Remember, you guys, you can use your Pear Decks as your notes. And so I kind of mentioned to you, I think it was yesterday, what you can do to just keep everything organized. You know, the paradox are great because it has all that information there, but they do disappear after 30 days. So since we just started a brand new unit, what you can do is go into slides, create a new slide file, and just label it Unit 4 Trigonometry. Go back to our paradox for the tangent ratio, go in and screenshot a bunch of stuff that's important. And then for today too, add this to your Unit 4 Trigonometry slides. Just go in and screenshot all the things that are important. Okay, so as you work on it and you get your work all done, take a screenshot of it, and you'll have everything in one place. So that way when you need to reference it, it's easy to find. When you have a test, it's all just in one big Google Slides file. I think that'd be a good way to do your notes in this virtual world. Okay, so we have a right triangle over here. This is DFE. The hypotenuse is this side across from the 90-degree angle. It's 17. The two legs are 8 and 15. And depending on which angle we're looking at, if we were looking at angle D, the acute angle D, or the acute angle F, they would switch positions. One way they're adjacent opposite, the other way they're opposite adjacent. And so we're going to write the sine and cosine of each angle as a fraction and as a decimal, rounded to the nearest thousandth, right? And so D is done for us, but we're just going to look at this. So I always like to color code things. So I'm going to go ahead and get my line tool. I'm going to put some colorful lines on here. Let me go ahead and make this match with, I'll turn this on student paste just because I'm going to make it match with these colors here. Okay. We're using green for adjacent, blue for hypotenuse, and red for opposite. Okay, so just trying to stay a little bit consistent here. So here I'm going to go ahead and do this as blue. And since we're going to first look at D, it'll switch. So first, this is the adjacent, this is the opposite side, and then this would be the adjacent side. Okay, just for this first example for A. The sine of D is the length of the opposite leg, D. So that's red over the length of the hypotenuse, over this blue here. And so if you write the letters that represent that, that's EF over DF. And if you plug in the values, it's 8 over 17. You simplify it and round it, we go from an equal sign to an approximately equal sign and get 0 and 471 thousandths. For the cosine of D, we're going to look at the ratio, the length of the adjacent, which is angle D, to the length of the hypotenuse, which is still blue. So green over blue, 15 over 17. Simplify it, you round, it switches from an equal sign to approximately equal sign. And now we're going to look at angle F. So when you do this, now that we're looking at angle F, the hypotenuse is still the hypotenuse. That has not changed. The length of the hypotenuse is still that blue side. But what's changing now is that my opposite side is now over here. It's kind of covering that up too much. So these can go back and forth between which one is opposite or adjacent, depending on which angle you're looking at, which acute angle you're looking at. Trying not to cover up the numbers, but then again, I am covering up the 90-degree angle. And so in this case, it's that way. Actually, let me do this because that's a little bit, I'll use pink and light green instead of red and regular green. I don't know if that helps, but you know, it's just because I'm trying to show the same thing. That's now the opposite. Okay, and then the adjacent is this one, this time for angle F. Okay, So maybe that helps a little bit. So we got to figure out what numbers go here and here. DE over DF. What numbers go here and here, and then we got to round both of these. So let's see how we are doing with this. Put this out here. Go to the slide and show some responses. And you can use the calculator to round. Use the calculator to evaluate that. Okay, so right here, this looks great. This is correct. Doing good so far. So this looks like 14. We have 15, 17, or 8. Those are only 3 choices. 15 over 17. Yep. You know, the color coding might get a little insane. You don't have to do the color coding like I do, okay? If you just want to put in the numbers, that's fine. But I have the option there for you if you do want to do that. So 15 over 17 is what we want to write. That is correct. 15 over 17. 15 over 17. Yeah, that's the opposite over the hypotenuse for acute angle F. Oh, that's a good idea. So you just write it in the color that you want it to represent. 15 over 17. Yep. Okay, so we're getting that far. So I'll go ahead and I'm just going to use black right now because I'll get too wrapped up in colors. 15 over 17. When you guys are using a calculator, I'm going to try to more consistently just use the Google calculator so you can see how that works because everyone has access to this one. And basically just, you know, here right now, it doesn't matter if I'm on radian or degrees because I'm not using one of the sine, cosine, or tangents yet. I'm just doing a simple division problem. I'm doing 15 divided by 17 equals, okay, we get all of that. And just to show you how to round in case we forget how to do that, I'm going to come over here and paste that number here. We want to round this. So when you're rounding, you can circle the place where you want to round to. Actually, you want to go the nearest, nope. I use orange. Thousandth, okay. And I go back and forth. I'm using so many different technology pieces that it's like I forget which one I'm using, which rules goes with which thing. So here we go, the nearest thousandth. So here's the tenths, hundredths, and thousandths. So I want to round to this place. You need to look next door. Depending on what's next door to the 2 will depend on if this stays as a 2 or if it turns into a 3. This number that the arrow is pointing to is 4 or less, so we're going to leave it as 0.882. Okay. Let's see how we're doing on the other one. So come back up to the top again. I already checked this person, they have it correct. So get your ratio first. Again, this person right here, this looks like 14. There's no 14. It's either 15, 17. What one's the opposite? You know, if you're trying to write with the Pear Deck, make sure you resize your pencil tool. Just click on the little resizer over there. Okay, so 8 over 17. Yes, that is what we want. This person did not round correctly yet. Okay. Yes, there we go, 8 over 17. So I'm going to come back over here. Let's type in 8 over 17. What happened to my 17? Okay, that's the adjacent leg over the hypotenuse, 8 over 17. And then to use the calculator, we'll show you how to round again, because I know that's a skill maybe you just forgot about. 8 divided by 17 equals this long number. So I'll come back over here, and we are going to paste it, and I'll make this larger. Okay, we're going to round. Oops. Well, I don't know what that just did. Pencil tool. All right, so again, we're rounding to the nearest thousandths. So circle where you want to round and look next door. Saying is 5 or more go up a floor. That means if this number that the arrow is pointing to is 5 or 6 or 7 or 8 or 9, then we're going to add 1 to the number I circled. So it's not 0.470. There we go, 0.471. That's correct. Question in the chat, will retests be available for the last test? Yes, they will. So we're going to do that next week. All right. So that is coming up. In the meantime, to prepare for that, go back through the pair decks that go with the last test. Make sure you understand everything in those past pair decks for the last test. If there's something you don't get, remember, all of our lessons are on YouTube. Just go watch the video again. All right, that should help, right? Because, you know, it's natural to like zone out and not pay attention, and then you miss something. Yeah, so I highly recommend you rewatch those YouTube video lessons if you're going to retake the test next week, which you should know how you did, and if you want to retake it. Okay, what am I doing? 0.471. I'm going to resize that so it fits. There we go. All right. And so we did this slide together. We did slide 6. We're going to do slide 7 together, and then you're going to do slide 8 during your acing time. And that'll be our day. All right. So let me hide our responses here. If you're still copying this slide, that's fine. You know, I'm going to move forward to slide 7 right now and explain it, and then I'll switch my slide to the next one. So write each trigonometric. Oh, see, I always have a hard time with this word because like I want to start sounding it out, but it's trigonometric. So like the no part, you don't really say that much. It's like not trigonometric, it's trigonometric. Write each trigonometric ratio as a fraction and as a decimal. Okay, so we were just doing that, right? We were writing fractions and decimals. Rounded, if necessary, to the nearest thousandth. Again, that's exactly what we just did. Okay, and so you can move on to this slide. The only difference here is we don't have, you know, all this information to help us figure out what's what. So we have to, you know, either come back to this slide to see if, you know, sine of A, I'm looking at opposite over hypotenuse, or I can go back to this slide, sine is opposite over hypotenuse, or even this slide, sine is opposite over hypotenuse, or I could just remember SOHCAHTOA, so S-O-H, sine is opposite over hypotenuse. So there's lots of little memory tricks to remember these. We're just writing ratios, okay? I'm going to go to the next slide here. I have one person on this slide so far. You're not forced to be on this slide yet. Let me see where we are actually. I'm going to go back because I don't want to move too fast for you guys, but we have some time here. We have 20 more minutes to do one more slide. So we're good on time, so I could give you some more time just on this one, depending on where you are. But you are on student pace, so if you're done copying slide 6, please move forward to slide 7. And a lot of you are done. Okay, you don't have to do all the stuff I did. See, like what this person did right here, they just wrote the fraction and the rounded correct decimal. That's all you really need to have on here. But of course, I love when you add more, as the more you add, I feel like the more you're understanding it. All right. So this person has the first ratio in, but there are a lot of you that are ready to move forward. Okay, so this person just started. 22 of you just started. So anyhow, I am going to start working on this with you. So I'm not going to force you to go to this next slide yet, but I'm going to be on it. Let's see. So, you know, when you work out a problem, if you didn't have a picture, my suggestions to you would be to draw a picture. Okay. If it tells you you have a right triangle and starts giving you information about that right triangle, it helps to visualize it. So maybe I'll just add some like extra text here to help you. I'll write it down here in this black area. Let's call it like helpful hints. Okay. Nope, that's not. Helpful hints. Okay. Draw a picture if you don't have one. Also, write down so toa to remember how the ratios go. So helpful hints. There's two of them. First one here, draw a picture. How about hint 2, use color if possible. I think that helps me. Okay, maybe that doesn't help you, but again, this is just a helpful hint. This is not like mandatory that you have to do these things. So if you totally get it, like you don't have to do any of that stuff that I just typed. But if you don't get it, these are the things I suggest to you. Draw a picture if they don't give you one. They gave us one here. Use color, okay? So I'm going to just kind of go back and use as a reference these colors, okay? I'm going to try to be consistent with that. So my hypotenuse is always, I'm going to use blue, I guess, or whatever color scheme you want to use. It doesn't matter. This is not like mandatory, but I like to do this. So I'm just going to put a line here, making my hypotenuse blue. Now, again, adjacent and opposite, these two are switching all the time. Blue is the only consistent one. So, you know, this side here, depending on, could be adjacent or opposite. This could be adjacent or opposite. Well, what am I looking at first? Sine of A. Okay. Well, sine, SOHCAHTOA, sine, is opposite over hypotenuse. All right, so let me put a fraction bar here. And then, well, in the numerator, the hypotenuse never changes. Okay, so I'm always going to have the same thing. 13, that's my hypotenuse, right? And then the opposite side to angle A. Well, where is angle A? So, you know, you need to pay attention to where things are. So I'm looking at angle, nope. Angle A, let's see, is it pencil tool, I guess? A is here, all right? So if I want the opposite side, you know, is it 5 or is it 12? So here's A. 5 is the leg that makes up A. So this is our adjacent. Well, opposite. Opposite for this case is going to be 12. If you're trying to color code your triangle, you know, these two are always switching, so that gets messy. Maybe just put color on the hypotenuse all the time. I don't know. It's really up to you. And so So we are going to then line tool here. So we wrote it as a fraction, and now we need to write it as a decimal. So if I go to the calculator, figure it out, 12 divided by 13, we get that. And again, we want to round to the nearest thousandth. So anytime you round, it's approximately equal to, so this wavy equal sign. And that's approximately equal to 0.923. That's the thousandths place. If I look next to the 3, there's a 0, so it stays as 3. And that's it. That's all I gotta do. All right, so let me go to that slide and see how we're doing over here. Show responses. I have 10 of you here. No, I'm not gonna do that. Oh, look, this person has already really gone and done some stuff. Awesome. Okay. So we move on to the cosine. We're still looking at A, okay? The first two problems, sine of A, cosine of A. The last one's cosine of B, so that's when it's going to switch on us. But again, this is cosine of angle A, which is here. And I'm going to make a ratio. And this ratio for cosine, so CATOA, C-A-H, adjacent over hypotenuse. Adjacent to A is 5. My fraction is huge. I don't know why I made my fraction so big, but can I erase part of that? But yeah, look at that. Just like giant fractions for some reason. Okay. Denominator for cosine. So CATOA, H. H is always the hypotenuse, so that's 13. Yeah. So like if it's too crowded to do it all right here, you can do what this person's doing. They're kind of spreading out their work. That's fine. It's your work. You can draw little arrows pointing to where your work's going. Yeah, so now we want to round 5/13. 5 divided by 13 is this long number. So for rounding, it's approximately equal to 0.384 is what I'm gonna, 4 is in the thousands place, and if I look next door, there's a 6. So I need to add 1 to 4, so I get 5. And then our last one, cosine of B. Well, now I'm looking at a different angle. I'm looking at angle B. So what's a color I haven't used? Orange, sure. So anyhow, angle B is up here. And so now from this perspective, the opposite and adjacent have switched places. Cosine, so CATOA, adjacent over hypotenuse. So the adjacent side to B here is the one that touches it. So 12 is in my numerator. And then, why did I make that orange? I didn't mean to do that. adjacent, I was using green. Okay, and that's over the hypotenuse, which doesn't change. Doesn't matter if you're looking at A or B, your hypotenuse is still your hypotenuse, which is 13. Okay. And then we are going to round this to the nearest thousandth. To the nearest thousandth. Come back to Google Calculator. 12 divided by 13 equals. Okay. 0.9 2. 3's in the thousands place. Look next door. There's a 0, so it stays as a 3. And all right. So we did all these. That's it for the lesson. The last slide, when you're ready to go to it, is slide 8. Okay, and so you have another example like the one we just did. Your triangle's on its side now. You're going to find sine of D, cosine of F, sine of F. Use this to help you. Use this to help you. All right.